All right, good afternoon, everybody. Apologies that I ended up getting pulled into a meeting, so I cannot be in class today. Depending on the length, I might be able to make it, but really probably not until like your exit ticket. So, for now, you have a do now in front of you. Go ahead, take like 4 minutes, only 2 questions, should hopefully be quick. Evaluate these different function values. Go ahead and pause the video. All right, so if we're taking a look at this, the equation themselves are slightly more complicated than we've seen previously. If you take a look, we have, right, this lovely x cubed that is now there. Otherwise, if we're looking at just this part here, 2x minus 1, well, we've seen stuff like that before, quite a bit in fact. And then we're also being told to evaluate for h of negative 2. Now, hopefully, especially after yesterday, we all know that when we see h of negative 2, that this is an input, right? And when we have an input, as we've talked about so many times before, that means that we have to use substitution. So we're going to substitute this in. And so anytime I see an x, I'm going to substitute in a negative 2. Now, the only thing we have to be careful of here is that we have more than one x now. And so, come down here for our work, h of negative 2 going to be equal to negative 2 cubed, make sure that negative stays inside the parentheses, plus 2 times negative 2, again the negative staying in parentheses, minus 1. Awesome. From here, we're just going to go ahead and work this out. Negative 2 cubed, well, that's going to be negative 2 times negative 2 times negative 2. That's going to be negative 8 plus 2 times negative 2, well, that's a negative 4 minus 1. And so really what we have here is negative 8 minus 4 minus 1. Well, if we combine all of these terms, we're going to find that h of negative 2 is going to be equal to negative 8 minus 4, that's negative 12, minus 1 more, it's going to be negative 13, option D. Taking a look at number 2, again, slightly more complicated or just sort of more going on than we've seen previously. However, again, input, so again, substitution. So g of 4 is going to be equal to 4 squared minus 4. From here, 4 squared, 16, minus, well, just 4. And so the g of 4 is 12, which is A. All right, hopefully those two were pretty easy and pretty quick. Again, it's just using substitution because we're being given inputs. And remember that we know that we're being given inputs because we are inside the parentheses on these values. Inside means inputs. All right, go ahead and take out your notebooks and open up to your table of contents. Go ahead and pause the video, and once everybody's open, we can take a look at our header. All right, so today, our header, I know I don't really have it here, but it's going to be 3.04 functions in context. 3.04 functions in context. Make sure you have that in your table of contents, and as soon as you do, please go to a clean page. Once you're at that clean page, go ahead and repeat our header. Today is the 29th, 11:29. And as soon as you're there, take about 2 minutes and write down this statement here, please. This is going to be the word problem and example that we look at for today. There it is. Pause the video, and as soon as everyone has this, we can bring it back. All right, so we have our lovely example, right? At a local pumpkin patch, you can pick your own pumpkins. There's a $5 charge to enter the patch. So I've got this lovely $5 charge. And then 25-cent charge per pound of pumpkin. All right, so we have this piece here. Let P represent the weight of the pumpkin and you choose, and C of P represent the total cost of the pumpkin in terms of the weight of the pumpkin. Now, already they're telling us what our variables are. Awesome, we're going to go ahead and use those. We want to be able to write a function that we can use to model this scenario. Now, think back to when we were using just regular old equations, right? We would generally have something like y is equal to mx plus b. We're going to have something that looks super, super similar, except that instead of y, we now want to use this lovely c of p combination, because we want to use function notation. And so when we look to write a function, we're going to have that c of p, right? The cost per pumpkin is going to be equal to, well, it's going to be the weight of our pumpkin times that 25-cent charge, so 0.25p, plus that $5 as our initial charge to enter the pumpkin patch, right? Think of this as like when we were setting up cell phone plans where we always had a monthly cost plus a startup fee. Again, we have this times a cost per pound and the initial entry fee. And so now we want to know, okay, well, how much will we spend if our pumpkin weighs 10 pounds? Well, this 10 pounds right here, that's going to be a p-value, right? And so we're going to have p is equal to 10, which in turn, right, because again, thinking function notation here, means that we want to find the c of 10. When I want to find the c of 10, I know I'm working with an input, so I know I'm going to use substitution. And so the c of 10 is going to be 0.25 times 10 plus 5. Well, 2.5 times 10 is going to be 2.5, or sorry, 0.25 times 10 is 2.5 plus 5. And so the cost of a 10-pound pumpkin is going to be, remember, we're working with money here, $7.50. Again, $7.50 for that 10-pound pumpkin. Okay. Well, let's look at C, right? As we've seen previously, when we have a question like C, when we see that both values are filled in and we want to know what does this represent in context, what they're really looking for us to do here, right, with this chunk of this question, is we need an interpretation. We need to interpret. That's what we're looking to do. And so we have this lovely p-value. So p is equal to 8. And remember, this represents the pounds, or the weight of the pumpkin we chose. And then we have this c of p, right? Specifically 8, yes, but the c of p is 7. And so remember that c of p is a cost, specifically in dollars. And so if we're looking to write a sentence, which when we interpret, we should be writing a sentence, we're going to name everything that we just listed. And so what this represents is you will be charged a total of $7 if, I'll say /when you pick an 8-pound pumpkin. All right, I'm going to scroll up ever so slightly so that we can sort of see everything. Go ahead and pause the video here. Make sure that you've got all of this in your notes. And then as soon as you do, you can unpause. All right, so now that we've gone over that, you're going to dive right in with some problem set A. So go ahead, make sure problem set A is in front of you. All right. And so if you take a look, problem set A is asking us to do something very, very similar to the same style that we did in our notes. You have some information, you need to write an equation, use a value to solve. Again, solving for a value. And then part D down here, asking you to interpret. For right now, just work on number 1. You're going to start silent and solo, please. And you're going to have 6 minutes to work through number 1. Go ahead and begin. You can pause the video here. All right, so your 6 minutes are up. And let's take a look and go over and see how we did. So if we read this, we have you're skiing down a 1,350 meter ski slope at 60 meters per second. Let t represent your skiing time in seconds, and d of t represent the distance from the bottom of the ski slope. All right, so we have this lovely total right here, right? Like that's the total size of the slope, and we're going 60 meters per second. We want to write an equation for d of t. Okay, well, d of t is going to be equal to, right, because this is distance from the bottom, 1350, because that's the total, right? That's the top of the hill, minus 60, it's that 60 meters per second, times however many seconds we've been skiing, which is t. And so our equation should be d of t is equal to 1,350 minus 60t. Okay, let's take a look. How from the bottom of the slope we mean 5 seconds? All right, 5 seconds, that's going to be a t value. T is going to be equal to 5. If t is equal to 5, that means that we are working with an input, which means we should be substituting. And so d of 5 is going to be equal to 1,350 minus 60 times 5, which is going to be 1,350 minus 300. And so the distance to the bottom after 5 seconds, right, d of 5, that's what that stands for, is going to be 1,050. Oops, sorry, not feet. We are working in meters. Working in meters. All right. Now, if we look at part C, we're being told, okay, well, if d of t is equal to 810, solve for t. Well, this, right, first time we're seeing it today, but hopefully we recognize that this is an output. Again, the reason we know this is because it's outside of the parentheses. When we have an output, we set this equal. We take this lovely value and we set this equal to our function. And so 810 is going to be equal to 1,350 minus 60t. And from here, our goal is to solve for t. So we got to isolate that. And so what I'm going to do is I'm going to subtract 1,350 minus 1,350. And I'm going to have, well, when I perform this subtraction, is going to be 540, specifically negative 540 is equal to negative 60t. On both sides, I'm going to divide by negative 60. Turn that t is going to be equal to 9. And so d of 9 is equal to 810. Remember, this is seconds. And so now we want to interpret what we just wrote, right? And so I know that this is seconds, and I know that this is meters, specifically from the bottom. Right? I want to be clear, this isn't how many meters we've traveled, this is how many meters from the bottom we are. And that comes from, back up top, that last sentence right here, right? D of t represent the distance from the bottom of the ski slope. And so if we're looking to write this in context, we will be 810 meters from the bottom after 9 seconds. All right, once again, go ahead, pause there, make sure you have all of this down. All right, so after this example, we're actually going to turn the page and we're going to jump to problem set B. In problem set B, you're going to work on your interpretation skills. Specifically, we're going to look at 1 and 2. I want us to look at 1 and 2. You are simply looking to figure out what on earth do these mean in the context of the word problem. take 4 minutes. Make sure you read these carefully, please. Please work silent and solo. Your time will start now. Go ahead and pause the video. All right, so let's take a look. Copacabana Beach in Rio de Janeiro is one of the most popular beaches in the world. P of T models the number of people at the beach T hours past midnight on a specific day. And so the question is, what does P of 10 equals N mean? Okay, well, let's see. Hours past midnight. Now it's going to take some thinking on our part. That means we are looking at 10 hours past midnight, which makes this 10 a.m., right? That means this is 10 in the morning. And so P of 10 equals N. Well, that means that we're going to be looking at the population, right? The number of people at the beach at 10 a.m. So let's see which of our answers lines up with that. There's an equal number of people at the beach at 10 a.m. and at N hours past midnight. Not quite. There were N people at the beach at 10 a.m. Ooh, this one sounds pretty good. Let's check C and see what we think. There were 10 people at the beach at N hours past midnight. Well, this doesn't really line up with our units. And so, in terms of interpretation, we're looking at B. All right, well, let's take a look at number 2. Princess Tower in Dubai is considered the world's tallest residential building, towering to 100 floors. T of N models the number of tenants living on the floor N of the tower. What does T of 30 equals 25 represent? Okay, well, N, right, the number inside the parentheses, is really the floor. And so this 30 is actually the 30th floor. This 25 right here, as we talk about up here, this Tn, so this function value, is the number of tenants. And so this 25 is going to mean 25 tenants, specifically on the 30th floor. Let's see what matches. There are 30 tenants on the 25th floor. Not A, that one reverses the numbers. The 30th floor has the same number of tenants as the 25th floor. No, that's not quite going to be it. The 30th tenant lives on the 25th floor. No, that's also not going to be it. In option D, there are 25 tenants on the 30th floor, 100%. That is absolutely what we want. All right. So depending on time, if you have more than 10 minutes, you're going to stick around and work on problem number 3. If, however, you are around 10 minutes left of class, you're going to go straight to your exit ticket. Whoever is filling in and covering for me will be able to tell you which one to work on. If you are going to your exit ticket, you have until the end of class, work silent and solo. Otherwise, go ahead and pause the video and have about 2 minutes to work on 3 or 3 minutes. Again, whoever's filling in for me will have a better timestamp. All right, let's look at question number 3. At the shoe factory in Los Angeles, California, each worker begins with a box of 1,000 sneakers. All right, we have this wonderful initial value right here. Every hour each worked is expected to box 150 sneakers. All right, so we're expected to box 150 per hour. Let f of h represent the number of sneakers remaining after h number of hours. Okay, so write an equation that represents f of h. Well, again, this is going to be really similar to our ski slope problem. F of h is going to be that initial value, that 1,000, and we're going to subtract the 150 that we should be doing per hour, which is h, or times h. And so if Jasmine's been working for 3 hours, how many shoes remain to be packed? Well, this is an h value, right? H equals 3. That's an input. We got to use substitution. F of 3 is going to be 1,000 minus 150 times 3, which is going to be 1,000 minus 450. And so the F of 3 is going to be 550 sneakers. We want to make sure we're putting our units. When we're given context, use and give context back. And so now we have, if Jasmine plans on working only 6 hours today, will she accomplish boxing all 1,000 sneakers? Provide evidence. So What we need to do here is we want to take the 6 hours and see that if we plug in 6 for h, similar to how we did with 3, are we going to be greater than 1,000? Well, let's take a look. F of 6, there it is, it's going to equal to 1,000 minus 150 times 6. It's going to be 1,000 minus 900. And so f of 6 is going to be equal to 100. Specifically, again, 100 sneakers. And because this number is positive and non-zero, that means no. Right? As we just did the math, she will have 100 sneakers left after 6 hours. All right, go ahead and pause the video here. Make sure you have all this down. All right, and from here, if you haven't gotten to your exit ticket, go ahead, jump to that exit ticket. You've gotten to the end of class to work silent and solo. I will be looking at them when I get back. Have a wonderful day, and you've got this. Thank you very much.